Okay, so in this video we're going to go ahead and show you how to write electron configuration using the periodic tables. This is one strategy. There's different strategies, but I think this is the one that's the easiest and makes most sense. So first we want to have a periodic table, and we're going to go ahead and label it. Okay, so I kind of explained to you that all of these elements here they're going to have electrons in the s orbital. Okay, everything here occupies what we call the s1 orbital. Everything here has 2 electrons in the s orbital, so we say it has s2. Okay, so that little subscript just tells us how many electrons are in that orbital. Okay, here we have the p orbitals. So everything in here would have p1. This would have p2. This would be in the p3 orbital, p4, p5, and last of all, p6. Okay, so it's helpful to have this labeled on your periodic table. Then this section here, this is where the ones in the d orbitals. So they have electrons in those spaces. Okay, so this whole thing here is the d orbitals. This would be d1 all the way to d10. Okay, I'm not going to write it all, but I can, for example, this would be D2, D3, 4, and so forth. Okay, I think as long as you have this labeled, then you're fine. And the side here kind of just tells us the level of that. So there's 1, 2, 3, 4, 5, 6, and 7. Okay, these we won't touch on these too much. These are our f orbitals, and remember f hold up to 14. Okay, so this is our f orbitals. Okay, and this here would be our f1 all the way to f14. Okay, if you notice, the periodic table goes up by atomic number. So here we have 1, so here we have 2, 3, 4, 5, 6, 7, 8, and so forth, right? So, but if you notice here, we have 56, and then it goes up to 72. Well, that doesn't make sense. What's happening here is that in reality, this actually goes there. So think about this whole thing. It's actually right in there. But why is it in the bottom here? Because it just looks easier on a piece of paper. It makes the periodic table fit better, right? Because if we were to take this big old piece and put it here, there'd be this long periodic table. So in reality, though, these two actually fit into here. That's what has those numbers. Okay, so just keep that in mind. All right, so let's go ahead and do electron configuration for a couple elements, and we'll go from there and see. We'll try a couple different problems. All right, so let's start with, let's say, lithium, right? So when we're doing these problems, we always have to start from hydrogen and work our way to the element we want, because basically all of these, remember, the off-ball principle tells us that the lower electrons have to be filled before we get to the higher ones. Okay, and all of these trends pretty much stay the same, except helium is the only exception. You can actually think of helium as actually being right here, and we'll go over why right now. Okay, so let's do beryllium. Okay, beryllium has 4 electrons. So I want to show the configuration for it. So first I start here. I go 1s1. That orbital will be filled up. 1s2, right? 1s1 and then 1s2. That's filled up. So I'm going to go ahead and write that down for beryllium. 1s2. Okay, so we're here, now we're down here. Now we're at the 2s1. That orbital has electrons in it. So I'm not going to put that down because I'll tell you why right now. Because we end up at the 2s2. So you don't write 2s1, 2s2. You don't write that, okay? You actually just write the last one, because the last one implies that one's already there. So it would be 1s2, 2s2. That would be my configuration for beryllium. It has 2 electrons in the s orbital, 2 electrons in the 2s orbital. Okay, let's look at a simple one. Hydrogen. Well, hydrogen, it only has one electron, and that one electron is in the 1s1 orbital. So it'd be 1s1. Okay? Alright, let's keep moving through some. So let's try one that's a little bit more challenging. Let's try phosphorus. Phosphorus has 15 electrons. So let's work through the periodic table until we get to phosphorus. Phosphorus. Okay? So I start here. Well, these two orbitals are filled up already, right? They're filled up. So my 1s2 is filled up. Okay. That brings me to here. Because remember, hydrogen, we're just pretending like it's right there. So this, I'm right here. Now, my 2s1 and my 2s2 are filled up. They're filled up with electrons already. 2s2. Okay. Now that brings me to my next one. So I'm trying to get all the way to 15. That brings me to here, right? Now we're not in the s orbitals, we're in the p orbitals now. So that's filled up with electrons. That, and so forth. Okay? So I'm going to put 2p6. I'm not going to put 2p1, 2p2, all that, because if I put 2p6, then that implies that they're all filled up already. Okay? And the reason I put 2p6 is, well, 2p6. Okay? Alright, then we're done with this. Now we're going down here. Well, if this was 2s1, 2s2, well, this is going to be 3s1, 3s2. That's filled up. So 3s2. Okay, we're almost there. We're trying to get to phosphorus. There's nothing here, so we just keep going. Right, there's no d orbitals. We get to here. That's filled up. That's filled up. That's filled up. What are we left with? 3. Go up. P3. 3p3. That's the configuration for phosphorus. Okay? Alright, let's do one easy one and then we'll go back to one difficult one. Okay? Let's do helium. Helium has 2 electrons. So remember, first we fill up the 1s1, then we fill up the 1s2. That's why we don't. There's no 1p orbital. That's not a thing. 1p6. That just doesn't exist. Okay, so that's why we can think about helium as actually being here, but it's here for other reasons due to the way it reacts, which we'll go over later. Okay, but that's why we kind of consider it to be there. Okay, so now let's do something that has to do with this D block here. Okay, so if we have something in the D block, these are actually they're actually one energy level lower. Okay, so I'm going to go over what that means when I'm doing the problem. But let's go ahead and let's do magnesium, right? Magnesium is 25. Also, another thing that you should check, your electrons should equal the total of electrons. So for example, phosphorus has 15, right? It has 15 electrons. So my configuration should have 15. If it doesn't, then I did something wrong. So let's test that. 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 plus 3 is 5. 10 plus 5 is 15. Yes, that's correct. Okay, that's just a way to double check your work. So let's do magnesium now. Magnesium has an atomic number of 25. So it has 25 electrons. Let's work through the whole periodic table till we get to there. So M, N. Okay. All right. So now we go. This is filled up. This is filled up. 1s2, and it just becomes repetitive. Okay. That brings me down here. 2s1, 2s2. 2s1, 2s2 filled up. Okay. Now my 2p orbitals are all filled up because they all have electrons in them. Because we're trying to get to that last orbital. 2p6. Okay. That brings us to here. Now we're at the third level, 3s1, 3s2. That's filled up. 3s2. Okay. Then we're here, right? We've already done this. 1, 2, 3, 4, 5, 6. 3p6. 3p6. Okay. Now we are same thing. It just becomes super repetitive. 4s1, 4s2, 4s2. Here comes the tricky part. Now here's magnesium, right? It's D1, D2, 3, 4, 5. So you probably think it's going to be 4D5. However, that's incorrect. This whole D block is one energy level lower. So one, I'm just going to put level lower. So rather than being 4, this is actually going to be 3D. Okay? So it's 3D1, 3D2, 3D4, 3D, 3D3, 3D4, 3D5. This would be 3D5. And if you counted if you counted them up, you would see that you have 25 electrons. Okay. All right. So if this is, and that always stays the same. So all of these are always 3D. They're always lower. This was not. This would be one lower than this, or this would be 4D. This would be 5D, and so forth. Okay. All right. Now, the last thing I want to go over is how do we do abbreviated versions, which are short versions. They're what we call the noble gas electron configuration. So first, where are my noble gases? My noble gases are this last row here. Okay? It's this whole block here. Just let me highlight that. Okay, so this is just a way to do electron configuration, but in a shortened version, basically. Okay, so let's look at some examples. Let me do the electron configuration for beryllium. Okay, beryllium. So beryllium. In order to do the configuration for beryllium, I have to go find beryllium. I go up one, and then I find the noble gas before it. The noble gas before it is helium. So I write the symbol of helium. Okay? Then I start doing the same thing that I was just doing, but now I start from helium. So I go from here, I go 2s1, 2s2. 2s2. And that's it. It's just a shortened version. And it means the same thing, right? Because if we look at before, this was our configuration, right? And 1s2, well, that's just helium. So basically, this takes the place of this. It makes it shorter. Okay, and it makes some of the longer ones a lot shorter. Okay, for example, let's look at calcium. Calcium is here. So let's do the configuration, the noble gas. Sometimes you'll hear it called the abbreviated version. So the noble gas configuration. Why is it the noble gas? Well, because we start at a noble gas. Okay, so we go up one, then we find the noble gas. So we find the noble gas before it by going up one, then to the right. So it's argon. So I go ahead and I put argon. Then I just start from there. Okay, so from here I go down to here. 4s1, 4s2, 4s2. Then I'm done. That's it. Okay. How about let's do one for magnesium? We already did that one, right? So let's do it for that. All right, manganese. Sorry, manganese. Magnesium is another compound. Okay, so same process. We're here, go up and all the way to the right. It's also argon. Okay, also argon. Okay, now, well, we just started argon to do the same thing. So it's 4s2, 4s2. Remember, one level lower. So This is going to be not 4D, but 3D. 1, 2, 3, 4, 5. 3D, 5. Okay? So if I were to compare it to my previous one, pretty much what it's telling me is that argon just represents all of that. Okay? And we end up just putting the last part, this last part we put here. So it's just a shortened version of it. That's all it is. Okay? Okay, let's do one more example just so we're feeling a little bit more comfortable with it. Okay? Let's do something that's kind of difficult. Let's do indium. Alright, so indium. I go up and I go to the right. That gives me krypton. Okay? So indium here to the right. For indium, I start at krypton. Then I go and I do the same process. So from krypton, I go 5s1, 5s2. I'm basically going to fill them up until I get to what I want, which is indium. Okay? So that's filled up. 5s2. Okay? Now we get to this next part. Remember, D is always one lower, so it's not 5D, it's 4D. Okay, that's going to be filled up, filled up, filled up, filled up, all filled up, all filled up, till we get to here. Okay? So 4D 10. It can hold 10. We can verify that. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Then, even though this is lower, once we get back to the P, we actually go back to the regular counting. So this is not 4P. This is just the regular 5 P1, and that's it. 5 P1. Okay, we could, and then for example, this would be 5 P2, 5 P, and so forth. Okay, same trend. Okay, so that's pretty much it. That's how you write electric configurations. I know it's a little bit difficult, but I will also be providing you with a few other resources to review this.